turn for presenting a forecasting tool. This is a classical tool in the energy sector, but I'll try to give some points. My name is Joaquim Meléndez. I'm a telecom engineer and a PhD in industrial engineering. I'm a member of the Electric, Electronic and Automation Engineering Department at the University of Girona, here in Catalonia, in Spain. And I am also leading with my colleague Joan Colomé a research group, the UdG-eXiT research group. This is a research group devoted to the application or to the study of artificial intelligence principles and their applications to solving engineering problems. In particular, we focus on data-driven solution and also in optimization methods. And we are working in the energy domain from the last 12, 15 years. Okay. If we go into the problem, maybe the majority of you knows about the meaning of energy forecasting. The basic problem is to know how much energy should be delivered or will be produced or will be consumed at a specific point, at a specific time instant, probably specifying also some extension in time, this time horizon, and probably also with some resolution or granularity. Okay, so this is the basic problem. We are focused in the project on both generation and demand forecasting. And in case of generation, we work or we deal with the problem of PV, photovoltaic generation, because the problems it could cause in the distribution grid. For doing the forecasting, what we need is basically learn about from data. The basic data we used in this project is data from the smart meters. So the goal is to predict, to forecast the consumption at the customer points. And for this, we use the data from these devices, but also other contextual information as the weather and the calendar. Okay, this is the way we work in this problem. But of course, depending on the application domain, other data sources could be added to get more significant results. Okay. So what are the applications of energy forecasting tools? There are many in the energy sector. For example, for those that are involved in demand response or flexibility programs, it's an interesting tool, since if you want to participate from a market-based point of view, it's necessary to know the capabilities of your customers. For example, if you are an aggregator, or you need to know how the consumption or the demand will be in the future in the grid, to ask to demand this flexibility in those markets if you are a DSO. Also, if you are DSO and you are involved in the operation and management of the grid, it could be necessary to identify possible critical events, those that my colleague Francisco told, for example, congestions in the grid or variations in the voltage, over voltages, sub voltages. And if you could forecast, for example, based on this generation and demand forecasting for the next hours or for the next day. Also for the communities or for people that is involved in the energy management or in applying energy efficiency solutions in specific grids or communities or hubs or buildings, energy forecasting it's a critical point to schedule or to manage the assets, to charge, discharge batteries, or to schedule the operation of some specific loads just to get some energy goals. Also, people, the energy services companies or people that are involved in energy management programs would be interested in creating baselines and from this estimate the savings of specific actions. So it means manage energy in measurement and verification projects, following the international protocols for this, or also people that is in charge of just controlling the energy budgets in the institutions and wants to give or to have some estimation of the possible energy consumption in the next days or months, depending on this concept of granularity. In the results project, we mainly focus in the second and third points, so in the use of energy forecasting for the prevention of these critical events, and also on the use of the forecasting for better scheduling some assets or reconfigure the grid for an optimal management of the energy in the low voltage grid. Okay. What are the principal, since the forecasting problem is a well-known problem, what are the principal drawbacks in adopting a solution? And from this perspective, we have worked on providing a solution or general solution or adaptable solution for the problem. For us, the main problems are these three that we point on the left part of the slide. This is the adequacy of the energy forecasting methods or solution we have to the problem that should be solved. We faced these different problems in the previous slides, so for all of them, the solution should be different. Another important point is the quality of the data, quality of the information. So usually the people that want to do forecasting has a lot of data, but usually this data has a poor quality. And the last one is the quality of the method itself. So from Resolve perspective, what we develop is this solution for forecasting that is based on state-of-the-art algorithms. We are continuously updating this. And then we tried to develop a solution that could be easily customized to different problems, and with the objective to embed the solution into the business flows and business logics of the applications we are dealing with. Okay, and also to face with the problem of data quality, we have some different pre-processing strategies to check the integrity of the data according to the application, and also to filter or to pre-process the data in order to fill or replace some missing values or wrong values. Okay, just as example, in the project here on the right part of the slide, you could see the requirements or the application we have developed for the project. In this case, we wanted to do forecasting at the customer level. It means for each smart meter, we want to do forecasting of the demand, of the energy demanded at this point. In this case, we want to do day ahead forecasting, but the restriction for this is that the data we had for doing the forecasting was the data from the day before, because the data is consolidated in this time. So this is a problem, and we should deal with this. And from the perspective of the methodology, we use some called random forest and train with two models. From the perspective of forecasting, instead of using a machine learning strategy, in this case, we adopted a simple model based on the radiation in the site, and also then we are continuously adjusting the gain in order to cope with the seasonality of the model. Okay. And this has been integrated into DMS, into the distribution management system, just to support the operation and the management of the grid. This is quite a simple view of our solution. On the right, we have the algorithms we developed for data processing, for machine learning, the models for the generation. And we develop in the modular way, so it's easy to develop a custom application. So we only have to develop this green square, that this is the orchestrator or the application that manage all the data flow in order to do the training of the algorithms or the forecasting when this is required. And also it has an additional benefit that we not only have the processing algorithms, but we maintain a database with the results, so it's easy to make queries to these results and visualize or use for different purposes. So finally, this is easily integrated with customer applications by using an API on the basis of web services. Okay. So, for example, the application we told before could have a simple interface like this, and now I will show just to see the flow of data, how it runs, a short video where we manage all the data. Let me go with the video. In this case, for example, we have a data file with weather. Instead of the data file, we could ask to some agencies. Here is the sheet with data from the smart meters. We also could have other, in this case, that use casting of critical events. And with the application, in this case, we will upload the file. We can select the training or forecasting application operation. In this case, we are in the training mode. So the file has been uploaded, also converted because we work for integration with JSON files, and then we call with the web service. So in this case, it's just to show the step-by-step how it runs. So it's clear that in a real application, the flow will be automatically performed. After calling this web service, now we are training for all the customers that are in the file, a specific model. Now the application informs that it has finished. So we can also train for generation, the different models. They have been created. And now we can proceed, for example, for the forecasting. We can request for a specific time, in this case, May the 9th. We apply for this. Well, again, we do the conversion because we are in a real case, we will send new data. And we call the web service for the forecasting. So just forecasting is performed. So now we have here on the left that we have this output for the 9th of May. And we could do the same for the 10th. Again, we update the file. We call the web service. Now we call the web service for doing the forecasting. So the results are being stored in the internal database, so we can consult and access to them when we need. In this case, for example, we can visualize the forecasting for one day. This is a 1 day forecasting, 24 hours with resolution of 1 hour. And also, this is the generation. In this case, we agree with the partners that for generation, we will give negative values, just it's a convention. And since we get the data in the database, we can also access and visualize with different support. No? For example, in this case, we have a geolocalization of the consumption, so we can get where we can query the data and visualize for different purposes. Okay, so this is another example. For these numbers on the left are just the nodes, the points in the grid where we have the connection of the smart meters. So we are visualizing the consumption at this and generation at this point. Okay, so this is just a simple demo to show the flow, how it's managed from the perspective of the web service that provides the forecasting, and this has been integrated in the overall resolved solution. So we don't need to load the files and all of this, but we have integrated in the distribution management system, so the access to the metering data system is done automatically through the enterprise service bus. Then this is the one that calls the forecasting services and integrates into the whole the whole distribution flow. So we can use this data for the detection of the critical events. We can use the forecasting for better scheduling the assets in the grid, or for improving strategies for loss reductions or the prevention of the critical events. From the perspective of exploitation, I want to highlight that we offer the forecasting as a service. So this is something that could be integrated with any application. And this integration is goal-oriented. So there is one part of the applications that should be customized for specific requirements and integrated with different existing monitoring and energy management tools. Okay. So our target players could be any energy facility managers, ESCOs, DSOs, aggregators or market players that are interested in energy forecasting, energy communities, or any energy player, and also integrators that work in the area of energy. Our suggestion as exploitation formula is this customization for a specific application, and then a license for the use of the services. So this is a software as a service approach. Okay, and we offer this continuous evolution on the state of the art of the methods. Now we are working on an extension for multi-vector system, not only for electricity, but also for different energy vectors that are for example, in a hub. And also we offer the integration of this forecasting with other artificial intelligence-based services, for example, scheduling applications or statistical monitoring strategies for fault detection or anomaly detection in specific applications. Okay.
Presentation without wasting any time, because after this we will have a short break as well. So maybe Montse, I think you might have some questions on this possible connection to forecasting tool. Please go ahead.
No, thanks. Actually, my question I think was answered to the end, because I was wondering how much do you need to integrate with every context that you work on and the systems of your clients. But I don't know, our understanding is that there's quite a few forecasting tools out there, and it's a very kind of competitive space, talking kind of on the market perspective. How do you plan to deal with that? What's your key differentiation points there?
What we offer is our expertise on the domain. So we are a university. We are not a company that is devoted, that is already in the market. So we offer the expertise on those domains. So it means that we are in the state of the art of those methods, and we offer this forecasting adaptability to any necessity. So we are not at this moment. We are not offering a specific solution for a specific segment, but the capacity to adapt to these different approaches. So the idea is to build specific applications for those who require it, that has specific needs. So okay, we are open to adapt.
Yeah, perfect.